Welcome to this lecture on big data. In this lecture, I am going to deliver what is big data, what sources form big data, and what are the software technologies available to analyze the big data, what is its need to analyze the big data, and what is the importance of Hadoop framework, what are the modules or projects in Hadoop, and particularly here I am going to talk on Mapreduce processing. So this is my content. First, we focus on big data. Big data is the today's buzzword. It's a catchword. Everyone, the whole world is bundled with lots of data. Take internet, social media, electronic gadgets, all deliver some sort of data, and everything is stored in the internet. So we are in the data-driven era. So what is the need of these data? What we are going to do with this data? We have to think of the procedures, the technologies available must be utilized to process the big data so that the humanity, the society would be benefited. That is the purpose of analyzing big data. So first of all, big data, as I told, voluminous, massive data. And since it comes from many sources, the data altogether is structured and unstructured. So we can analyze both categories of data. The voluminous is there and structured, unstructured data are also there. So all these must be analyzed to give a meaningful result, right? And this big data, which comes from many sources, as I right now pointed out, it comes from internet, social media, it's another area where voluminous data is existing, and also mobile data. So these have to be analyzed. For that, what is the software technology available? Before that, what is the purpose of analyzing this data? Right now, some technologies are available. Hardware is also mushrooming. The specification of hardware is also mushrooming. But the problem is, what is the amount of time taken? What is the cost of those hardware, right? And if you go for the recent technologies like Hadoop, the cost is reduced and time is also very much reduced. That is the advantage of going the new framework, new tools, particularly Hadoop. So Hadoop is the framework designed by Apache, right? And that is an open source framework which is available to analyze, to process the big data. And this Hadoop has lots of projects in it, lots of modules in it. The very important are HDFS, Hadoop Distributed File System, then Hadoop Mapreduce framework, and also Hadoop Yarn. These three are very, very important. Right now I am going to concentrate only on the Mapreduce processing. Mapreduce is as the name indicates, this follows master-slave architecture. And also HDFS, as the name indicates, Hadoop Distributed File System. Therefore, this framework is capable of processing distributed data. Of course, parallelism is inherent. So this is Hadoop framework, and how to use this Hadoop framework? That is the next question mark. How to use? How to install it in my system, right? And for that, here I am using the Linux platform, the internet, that is the tar file, the Hadoop tar file. The version I followed is 2.6.0, and that is there in the internet. You download the tar file and you keep it in a particular folder. And here I am using a folder, a particular home folder, and there you should keep that particular file, right? And you unzip it and tar it. Now the Hadoop file is ready. And next steps. First, Hadoop is an open source framework. It was designed using Java. Therefore, your system should have Java. Check that whether Java is there or not using that command Java-version that tells whether Java is there in the machine or not, right? Afterwards, suppose if the Java version is not there, you try to install it in your system. That is the first requirement. Second is you have to create a new user called Hadoop to work with the Hadoop framework. Create a Hadoop user. For that, if you are familiar with the Unix platform, you can very well know the command. It is user add. And very important point is you should have administrator account to use all this. Then only without problem you can install Hadoop software. So create the user called Hadoop using user add command that is created. Then if you want to provide password for that Hadoop user, you can use it very well. The normal command is password. Give password to the Hadoop user. If you want, you can go. you can give the password, otherwise no problem at all. So after that, right, the keyword access that must be provided to the particular account, right? Keyword key based account that must be provided. For that keygen command, SSI keygen, that must be given, and that creates the key, and that must be stored in the proper files. So this gives the proper account for the Hadoop user to access Hadoop framework. Then you check it, SSH localhost, that tells whether that account is ready or not. Now you have the account, right? Hadoop user is there, and Hadoop user can access everything. Next is certain files have to be configured. The very important file first is the Hadoop env.sh. That file must be edited, and that is kept in your home folder, that is Hadoop home. That folder has two important files. Of course, many directories are there. Bin, sbin, these are the very important directories. In addition, there is a separate folder called etc, which has the initialization files, right? The one file is hadoop-env.sh. This file must be edited. The reason is Hadoop uses two environment variables. One is Java underscore home, another is Hadoop underscore home. These two environment variables must be properly set. You just look at in which folder the Java version is there, in which folder you have installed Hadoop software, and those folders have to be specified in the environment variable in the proper, in the env.sh file, in the proper environment variables. So that is one side. Next is some configuration files must also be altered, right? And there are a few files, for example, core site.xml. This is one file, right, which is needed to specify the name node, because I told in the previously, Hadoop means it has basically, of course, it has lots of projects. HDFS is very important one. HDFS consists of name node and data node. Right? So this name node has to be created, has to be properly specified only through core-site.xml. This is kept in etc folder, and this file must be properly set. Okay, so this indicates the specification for the name node. Next comes the data node, and that is also kept in same hdfs-site.xml, and that is also in the etc folder. Right, and this file must also be altered. In the data, actually data node is nothing but the place where the Hadoop data are stored. Hadoop follows distributed file system. So a single node or many machines may form a data node. The data are distributed, and that is taken care of by data node. Name node is nothing but the node which has the details of the data, that is in what are the machines the data are stored, and what are the blocks used for a particular file. That is called metadata. So metadata is the duty of name node. So core-site.xml and hdfs-site.xml, these two files, they tell that which is name node and which is data node. So these two have to be properly set. And further, one more thing is Hadoop characteristics is one very important characteristics of Hadoop is duplication. If you remember relational databases, there the very big disadvantage we normally highlight as redundancy. Redundancy must be avoided in relational data, whereas if you go for Hadoop, that redundancy is a must. So therefore, when you specify the details for the data node, you have to specify about the replication. How many times the data need to be duplicated, that is called replication, right? So here I am following a single cluster, single node installation. Therefore, I am following only single replication. By default, Hadoop can store the data in 3 different places. The replication, that is called replication factor, which is normally 3. That is the default value. But if you want only one replication, then you have to specify that in hdfs-site.xml, where the replication is defined as 1. Right? So now the configuration files have been set up. Okay, so now the environment is set up, configuration files are set up. Now the duty is the name node must be formatted so that the data node is ready to store the data. Name node is ready to have all the details of the metadata. Right? How to format? For that, command is there. You keep your place in the home folder. In the home folder, I told lots of important directories are there which are used by the Hadoop framework. One directory is bin. This directory has many commands, of course. So what here we have to follow is HDFS, right? /bin HDFS name node -format. This is the command. This formats the name node, and by that your machine is ready to store the data in HDFS file system. Now the setup is ready. You can use the setup to process, to analyze the big data. So that I told the big data comprises sources, data from many sources. These data can be analyzed to get meaningful results. How to analyze? For that we should go for Mapreduce programming. Mapreduce is one of the projects of Hadoop. And this Mapreduce follows parallel processing, distributed processing. Just again I want to remind, HDFS, this is the file system where the data are stored in a distributed manner. That is one side. With respect to big data, the data have to be stored in many places, right? That is satisfied with HDFS. Another point is the distributed data have to be parallelized, have to be taken and analyzed in an effective manner. That is the duty of Mapreduce framework. And this Mapreduce, how does it work? That we'll see now. So as the name indicates, Mapreduce, right? So here there are two activities, map as well as reduce. Mapper, as the name indicates, mapper, an object is mapped to another object. This is in general the definition for mapping. Here also in Hadoop, the Mapreduce framework takes the input as key value pair. That is the base. So that we say as a primitive. That is, primitives for Mapreduce framework is nothing but key value pairs, key value pair. And also very important point is, here the Hadoop analyzes the big data, right? The size of the input which you can give to the mapper can exceed the size of the hard disk. So that you can imagine how much data the Mapreduce framework can analyze, right? In HDFS, one block size is taken as 64 MB, simple block size here. Here is 64 MB, that is the size. So using these informations, you can imagine what is the size of the data the Mapreduce can process, what is the size of the data HDFS can store, right? Now the input is given in the form of key value pair. Whatever may be the input, right, that must be given as a key value pair. And one more point is, mapper always takes a single line as input. This is normal, right? This we have to remember, and if you understand this point, you can apply this fact to any problem, whatever you want to analyze, right? So always take single line as the input, and that must be divided properly as which is key, which is value, right? Key is not a very big thing. Key, of course, normally that is in many problems, key is nothing but an offset, a number, right? The entire line is taken as value. So key value for a mapper is this one. Mapper takes some input, the key value in the form of key value, and processes it and gives some result. Okay, and that is passed to the reducer. Right? Reducer takes the output from the mapper and it processes the input, and also again the output is nothing but key as well as the final value. This is the in general the components, the processing of Mapreduce. Right? And here the example I have selected is weblog files. How to analyze weblog files, right? Weblog is a very good example for big data, because whenever you click a web page, 100 bytes of data are stored in the web server. Just you can imagine how many users are accessing. What is the number of clicks for a particular user? Therefore, how much data are stored in the web server with respect to a single click, with respect to a single user. Just you can imagine whole world, if one server, Google server is accessed, what will be the size of the log file, right? And now this is an example of a big data. Now this log file, as it's voluminous, right? Voluminous, so therefore it can be analyzed by Mapreduce program, right? Now this web server, that log file in that any server can be taken out, right? What is the objective? Why do we analyze a log file? Lots of that is applications are there, because when you analyze a log file, lots of information, namely user behavior, can be identified. Right? The business trends can be accordingly the business trends, decisions can be taken. So this is the application of analyzing a log file. And this log file, I have a monitorware.com. This is one site from where I have taken that log file, right? And a simple, that is the format of a log file you can see on the screen. Any log file has a format, right? The IP address of the server, and the date and time, the type of method used, and the page access. So these are the basic attributes of any log file, right? These details are available in the web server, and this detail is analyzed by the Mapreduce task, right? As I told, for a mapper, this log file key value is nothing but keys offset. The entire line is the text passed to the mapper, and here I have designed a Java file, right, which has the full content of mapper, reducer, and a driver, right. Any MapReduce task can be written in any language, not in any language. Basically, as the Hadoop is designed using Java, Java is accepted. Apart from that, you can use Ruby, Python, and also you can use normal scripting language to design your mapper, reducer, everything. Now, here I have used Java to design the mapper reducer for my problem to analyze the log file.
So now you are seeing the login screen. So let me type my username and password. Now we are going to run the Mapreduce job in the Hadoop framework. Therefore, you must enter into the root account. So for that, SU is the command available, and you type the admin password. Then you can enter with the root permissions. Therefore, you can do whatever you want under the Hadoop. Right. So this is my home directory. I have checked it. I have kept all the Hadoop files in a separate folder. So let me go to that folder. Again, you can check what are the files. Yes. Okay. Here we are going to use Java, right? The Mapreduce functionalities are written using Java right now. Therefore, let us see what are the files we have created. So many files, and here the example I have taken is 2 process weblog file. Therefore, I have created a separate Java file called log analyzer, and we will see what are the contents, how that log analyzer was designed. Here you see the various packages. You have the core package IO and Hadoop based packages. Lots of packages are there, and we are going to run the Mapreduce job. So therefore, the classes, functions which are there in the Mapreduce packages are imported, and this is the main class. And here I am designing a mapper. You can have any name, whatever name you want to use, you can have it. And within the mapper class, I should create the map function, right? This is the map function. So this is the entire map function. With respect to that server log file, the function of the map is just retrieve the page request, because here we are going to count the pages. What are the pages viewed by various users? That is the objective. So therefore, in the weblog file, we have to count the page views, and this is the mapper function, and followed by reducer. This is the reducer where I have reduce function. Just look at the parameters which the reducer class takes. Reducer, extends, reducer. What are the parameters? Key value pair. The input is key value, output is also key value. Key here is entire line, right? The page, text, int is count, which were provided by the mapper. So key, text, int writable are the two inputs received from the mapper. Text and int writable. the page as well as the count, the summation, the total count of every page. That is the output of the reducer. Okay, so this is the syntax, and within the reducer class a reduce function is defined. This reduce function should count the pages. It should find the total count of various pages stored in the weblog file corresponding to a particular server. Apart from that reducer, there is a main function. Already the main class we have seen at the top of the file, and this is the main function, so which has to start the mapper, and that is done here. And here the command line arguments are very important, because Hadoop takes input from the file, output is stored in the directory, the file in a separate directory. So this is the usage, this is the way it should run in Hadoop. So that is given here. So these are all the functional. This is called a driver class, because this initiates mapper, and mapper does the function and passes the output to the reducer. Reducer takes the input and process, and finally tells the key value of the particular problem. So now we have seen the Java file having mapper and reducer. Now we will compile it. We should create class file. So this is the command, Java C is the command, and you have to specify the various folders which are referred by Hadoop to compile this Java file. There are 3 folders. Just look at lots of jar files are kept in this common folder, and again another set of library jar files kept in this folder, followed by the Mapreduce jar files. So you should specify 3 different paths so that the compilation would be complete. Yes, it is over. Now you can see what are the files created, what are the class files that are created under the name log analyzer. So now you can see 3 class files are created. This is the main driver, this is mapper, and this is reducer. Nice. The next task is you should create jar file comprising all the 3 classes just now created. So this is the command jar create verbose file name. The file name is loganalyzer.jar, and this jar should take all the class files starting with log. Now the 3 classes have been combined and kept under one file name loganalyzer.jar. Now you can see the jar file created. Yes, the loganalyzer.jar is created. You can see the time also. Yes, log analyzer is just now created. Very good. Afterwards, as per the Hadoop syntax, the input file must be stored in HDFS. Output files are also in the HDFS. Therefore, what you have to do is the log file which you want to analyze, that must be stored in the HDFS file system, right? So for that you should follow the command this command tells Hadoop dfs-ls. The commands more or less look like Unix based commands, but they should proceed with hyphen. So this tells what are the various files and directories in the root directory of Hadoop file system. This is the command. So if you see, lots of directories have been created, and here we are going to use this pt log. This is the file, log file, which we are going to process. Okay. Now we should run the jar file which we have created right now. For that, the command used is /bin Hadoop jar. The jar file created is log analyzer, followed by the driver class name, which is also log analyzer, followed by the input file in HDFS file system where we have stored the log file pt log, followed by the output folder where we want to keep the output, which is nothing but the page views. Now the process is going on. Mapreduce started. Map just now started, therefore 0%. Somehow it is over 100%. Reduce started. Reduce is also over. This is the screen which tells the complete processing of Mapreduce functions, the complete details. Now the result is ready, which is there in the output folder which we have given just now. Now you can see what are the contents of that output file logout. For that, the command is bin Hadoop dfs-ls. I want to see the contents of the output folder which I have given logout. Yeah, see is two files, success as well as part R followed by 5 zeros. This is the result which has the page views of the particular web server. You can see the contents of that file using the normal cat. This is the file name. Therefore here the command is cat, which tells the real output we expect. Yeah, this is the result. You can see the page count of the various pages the users viewed in that particular web server. You see various pages. You see main, lots of pages. This is the page. Count is 3, count is 4, 12. So like that you can get the count. Followed 6, 11, 7, something like that. So this is the real count we expect, and this is the output from the reducer. You see 25. Lots of pages have been viewed many times. So this is the result. And this is the Mapreduce task. This is the result of this log analyzer program. So just you can see how much time this Mapreduce takes and what is the advantage of big data analysis, for which Hadoop is a platform.
Log file here I have analyzed to identify the number of page reviews by a user in particular web server, right? How many pages are reviewed by different users? That is my objective. Right, so accordingly I can update my server. That is the objective. So you can see the output, how many pages are viewed, what's the count of pages reviewed by many users. And this, just look at log file size is very, very high. If you take this log file and process in the normal software and hardware technologies, definitely the time taken will be very, very high. And also, if you look at the size of the log file, it won't fit in the normal hard disk, right? But if you move to Hadoop framework, you need not bother about the hard disk of a single system because Hadoop follows distributed category. distributed file system. The file, that is your data file, can be distributed, right? And everything is taken care of by the Hadoop framework. And you need not do anything on file opening, how to open a file, and what is the type of access I should give. Nothing is needed. Everything is automatically taken care of by the Hadoop framework, right? So you are giving the input, and just you have created a proper mapper and reducer, right? The function is over, right? The parallel and distributed task is done, and effectively you can see the results in less time. And you can take the results and you apply the decisions, and finally you can be happy using the parallel distributed processing of Hadoop framework. Thank you.